This is Math 2, 12.1 homework questions. That's Math 2, Unit 12, Lesson 1. Homework questions. You should have this worksheet either printed off my website or you picked it up from Clovis West. Okay, I'm going to go over a few. I'm going to go over 1, 2, 4, 5, and 6, and then some from the back page as well. Okay, starting off with number 1. Which one has the largest minor arc? So the minor arc is what we're looking at. So we're looking at this arc and this arc, and then we're going to look to see which one is the bigger one from those two. Okay, so what is the measure of each minor arc? Well, I know minor arcs are equal to their central angles, so this one is 80. Now, I don't know this central angle, but I know the major arc. The major arc out here is 279.5, and I know all the way around a circle is 360. So I'm going to do 360 minus 279.5, and you can plug it in your calculator or do it by hand. 360 minus 279.5 equals 80.5. So this arc over here is 80.5. And they're asking for which one is the larger of the two. Now they're really close. That one's 80, that one's 80.5. Which one is bigger? The 80.5. So that's B, letter B. That's circle A, that's circle B. So circle B is has a larger minor arc. Okay, now this one, I am going to find, there's going to be some extra work, and I'm going to find the minor arc. Now, because I write really big when I'm showing these problems, I am going to use a separate piece of paper. Okay, so let's see. We're looking for the minor arc. That's this right here. Now, what I do know, because they didn't give me a measure in here, they gave me that it's 2x. What I know is that this piece out here is also 2x. All right, that still doesn't give me a number. I need to know a number so I can figure out which one is the largest. So what I'm going to do is add my two arcs together. 2x plus 7x minus 9 equals 360. Now, why is that? Because again, I know all the way around a circle is 360. So if my minor is 2x and my major is 7x minus 9, the sum of those two will be 360. All right, so you're going to add 7x and 2x, you get 9x minus 9 equals 360. You go ahead and solve, add the 9, divide the 9, solve it, hit pause, solve, hit play, and we see if we end up with the same answer. Okay, I got x equals 41. So if x, that's not the measure of my minor arc because my minor arc is double the x. So 2 times x is 82. So this is 82 degrees. All right, now I'm going to redo the work for this one. Different numbers, different variables, same concept. Okay, I know that this minor arc is 2x minus 19, and I know the major arc is 5x plus 29, so you are going to set up your equation. 5x plus 29 plus 2x minus 19 equals 360. So that gives you like terms. 7x, 29, and negative 19 is positive 10 equals 360. Hit pause, solve, hit play, and see if we end up with the same answer. Okay, I end up with x is 50, but I do have to plug it in right there. 2 times 50 minus 19 gives me 81. All right, so again, they're close, This one's 81. This one's 82. I'm looking for the larger, that is letter A. So letter A is the answer. Okay. Now, you're going to do the same kind of thing down here. I'm going to at least set you up on these and then let you finish. Okay, we are looking for the smallest major arc. So this time we're talking about, this one was minor, we were looking for the largest. This one's now the major, and we're looking for the smallest. I know that's a little wonky. Okay, so the major arc is here. The major arc is here. And I'm going to look for the smaller of the two. Okay, so I don't know what the major arc is, but I know the sum of the two arcs is 360. 6x plus 22 plus 5x plus 8 equals 360. Then I'm going to do the same thing on this side. I know the sum of the two arcs, the major and minor, is 360, so I know that 4x minus 18 plus 3x equals 360. All right, now I'm going to let you guys finish this one on your own. Combine like terms, go down, go down. You get x equals a number. Here you're going to get x equals a number. And what you're going to do is the same thing we did over here. You're going to take those and plug it into that x. You're going to take this and plug it into that x, and you're going to figure out which one is the smaller of the two. Okay, so you're going to combine like terms and solve. You're going to combine like terms and solve. You get two numbers here, x equals 28 and x equals 47. Those two numbers are not the right answers. You get two x values, you're going to plug them in there, and you're going to get an answer here, an answer there, and you're going to figure out which one is the smallest, A or B. Okay, number 5, CB is a diameter. If CB is a diameter, that means it goes through the center and it's a straight line, which means it is 180 degrees. What is the measure of arc CD? Now they only use two letters, so it's the minor arc. CD is here. Now, in order to know what I know that this is equal to its corresponding central angle, but I don't know what the central angle is. So would you agree that if I knew what x is, I could plug it in and figure out what the central angle is? So how do we find x? We know that this is a straight line, so we know that 4x minus 20 plus x equals 180. I know that 4x minus 20 plus x equals 180 because this is a straight line. 5x minus 20 equals 180. Add the 20, divide the 5, get an answer, hit pause and solve. Okay, you should end up with x equals 40. 40 is not my final answer. They're asking for the measure of arc CD. So I know that this arc here is equal to the central angle, which is 4x minus 20. So I take the x and plug it in, just kind of like I did up there. So I'm going to do 4 times 20, I'm sorry, x is not 20, x is 40. 4 times 40 plus, nope, minus 20. 4 times x, which is 40, minus 20. So 160 minus 20 is 140. So the measure of arc CD equals 140 degrees. Okay, I'm going to do only parts of number 6. Now I'm going to read and see what information is given. Given circle C with diameter JR and KQ, and the measure of angle RCQ is 50 degrees. RCQ is here. That's 50 degrees. Use the definition for central angle and intercepted arcs along with triangle properties to find each of the following. Okay, So with just that one number, we're going to be able to find everything here. Okay, because of vertical angles, we know this is 50. Vertical angles are congruent. We did that like the first week of school, but you also learned that in previous math classes. Okay, what else do we know? We know that this here is a straight line. So what would this angle be in order to add to 150 to get 180? So you do 180 minus 50 and you end up with 130. And because these two are vertical angles, this one down here is also 130. And you can plug them in. 130 plus 130 plus 50 plus 50 should equal 360, and indeed it does. Okay, so now we're ready to solve. I'm going to jump around. I don't need to do all of them. The measure of arc JQ. JQ is here, and that arc is equal to its corresponding central angle, so it's equal to 130. Okay, the measure of angle CRQ, I'm going to do letter C. CRQ. Now we did something like that in notes. Where is CRQ? CRQ. So I'm looking for this angle right here. CRQ. Can you see that angle there that I'm looking for? I'm actually going to move it around this way. CRQ. I'm looking for this angle right here. I'm going to call that angle X. Now, what we talked about in notes is this is not part of my angle, but it's part of this triangle, and those are congruent because they're both radii for the circle. It's a radius, center to the edge of the circle, which means it's an isosceles triangle, which means the two base angles are congruent. So my equation I'm going to make is x plus 50 equals 180. X plus 50 equals 180. X plus 50 equals 180. 2x plus 50. I'll go ahead and solve this one all the way through with you. Subtract the 50. That gives you 2x equals 180. I'm sorry, 130. And then divide both sides by 2. And you get 65. Okay. And you guys can finish the rest of that section on your own. I am going to flip over to the back page. I do want to talk about 7 and maybe a few others. Okay, 7 has a lot to it. Let's read. Circle C with diameters JR, so this is a diameter, and KQ, this is a diameter. PL is congruent to JR. PL, and I said congruent, and I meant to say perpendicular. PL is perpendicular to JR. So I know there's a 90-degree angle here. You don't have to mark them all, but that's a 90, that's a 90, that's a 90. Okay, KQ, that's this line right here, bisects the angle PCR. So these two angles there are congruent. Why are they congruent? Because KQ, bisect means to cut in half, bisects the angle PCR. Answer the following. Explain why PQ, arc PQ, is congruent to arc QR. So why is this arc congruent to that arc? Okay, we would say PQ is congruent to QR, arc QR, because they are equal to their corresponding central angles. And the central angles are congruent, so those two arcs are also congruent. All right, what is the measure of angle 1 plus the measure of angle 2 going to equal? Now, we know that this is a 90 degrees, that this here is a 90 degrees, so 1 plus 2 is going to equal 90. What's the measure of arc JQ? Let's see, where is JQ? Now, they only used 2 letters. So, would I go JQ along the smaller way or JQ along the larger way? I would go along the smaller. Now, this triangle is going to get, the circle is going to get really marked up, so you want to make sure you're following, hitting pause and rewind if needed. Okay, so I have within the JQ, I have JP and PQ. I know this one here is 90. Oh, I'm going to do my work in here. Plus, what is this angle right here? What is PQ? Well, I'm going to write it down. I know this one's 90. This one is 45. Why? Because these two are equal, and 90 cut in half, and I know this big corner is 90, cut in half is 45. So, this is 90, these two little ones are 45. So I know that 90 plus 45 is going to give me the measure of arc JQ. 90 plus 45 equals 135. All right, I will do letter D, and then you can finish the rest. Okay, the measure of angle JRQ. JRQ. Okay, JRQ. Now, because this is going to get really messy, I am going to redraw the triangle and I will still do the work on the worksheet. Okay, so here's the triangle. There's the diameter JR. Here's another diameter that's perpendicular, and that diameter is called PL. And the center is C. And then all right, they're asking us to find the measure of angle JRQ. JRQ. J to R to Q. So I'm looking for that angle there. Now again, I just redrew it so that it could be a little more clear because my triangle was getting really messy really fast. Okay. So that's the angle I'm looking for there. I am going to turn it around like this. Now, I came from J to R to Q, but technically that's the same as CRQ. It's just a little confusing when they use the big diameter. All you need is this little piece here. I'm going to draw my triangle. I know that that's a radius and that's a radius, so those are congruent, which means the isosceles triangle base angles are congruent. I'll call this X and that X. My equation is going to be X plus that angle equals 180. What is that angle? Well, we said earlier it was 45. So I'm going to put a 45 in there. So X plus 45 equals 180. That's going to be my equation. X plus 45 equals 180, and I'll let you guys solve that on your own. All right, I'm going to jump down to some of the factoring. This is review. It says review right there from previous units that we did before we left school. Factoring. Okay, 3 terms. First thing I always look for, regardless of the number of terms, is a GCF. There's no GCF, which means the only thing it could be then is a trinomial guess and check. All right, The leading coefficient is 1, so that's good because it's just going to be x and x. My last sign is negative, which means my two signs are different. One's plus and one's minus. And then I list the factors of 40. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8. Okay, and then I'm looking for which ones will give me a -3 when I add them, but one has to be positive and one has to be negative. It looks like it's going to be 5, 8, and I'm going to make the 8 negative if I want it to be a -3 and the 5 positive. Now remember how we checked this before was 5x, -8x, and when you add those together, 5 and -8 is -3x, which works. And since we are just factoring, not solving, we do not have to set them equal to 0. This is it. That there is your answer. Okay, next one I'm going to do is 11. Remember what I just said in the previous problem, always look for a GCF first, and GCF is 2. So I take out a 2, that gives me x squared minus 25. Do you see that? 2 times x squared is 2x squared, 2 times 25 is 50, so that's my GCF. And then I look in here and I can see that's a difference of 2 squares. Because x squared is a perfect squared, 25 is a perfect squared, I double bubble. 2 is going to stay on the outside. X times x is x squared. 5 times 5 is 25. One's plus and one's minus. If you look back at your notes or if you watch the videos from this unit, I think it was unit 9. Difference of 2 squares, that's the way it works. What's the square root of x squared? X. What's the square root of 25? 5. X times x is x squared. 5 times 5 is 25. Those two numbers have to be the same, the 5 and the 5 and the x and the x. One positive, one negative, it works. Okay, number 12, what's the first thing we always look for? GCF. And what is the GCF? It is 3, and not just a 3, it's 3x. 3x times x is 3x squared, minus 3x times 2 is 6x. And then I look on the inside. Can I still factor? Is that a difference of 2 squares like this one? It is not, so that's your answer. All right, I'm actually going to do 13, and I'll talk about 14, but you're going to finish on your own. Okay, look for a GCF. Is there a GCF? No, there's not. So trinomial, guess, and check. Now, the leading coefficient is not 1 like it was earlier, so it's going to be 2x and 1x, because that's the only way to get a 2. 2 is prime. Now, the factors of 5 are only 1 and 5. Now, my last sign is positive, which means my two signs are the same. The neighbor tells me they're both positive. It's either going to be 1, 5 or 5, 1. Now, I'm just going to make a guess. If I put a 5 and a 1, is that going to work? 5x and 2x, is that going to add up to 11x? It's not, which means I have the 5 and the 1 in the wrong spot. So I'm going to put the 1 first. Instead of 5, 1, I'm going to put 1, 5 and check. 1x, 10x, and that adds up to 11x, which is the middle. I'm happy. This here is my answer. All right, and the last one, as I stated on all the previous problems, look for a GCF. There is, I'm going to give you a hint really quick, that one's difference of 2 squares. There is a GCF. It is 2, only 2. 2 times x squared is 2x squared, plus 6x because 2 times 6x is 12, plus 5 because 2 times 5 is 10. And then you look in here, is that a difference of 2 squares or is it a trinomial, guess and check? It is a trinomial, guess and check, and that's what I'm going to let you finish. So factors of 5, the signs are going to be the same. You want it to add up to 6, and then x and x, and you guys can finish that. That is it for this section.